Very much warm welcome to our the theoretical session for the laboratory manual entitled with Inorganic Pharmacy 2 Lab. Today we are going to discuss about the theoretical part for the experiment number 2. The experiment number 2 is the manufacture of aluminium hydroxide gel from the supplied material. So let's start with the theoretical part for the experiment number 2. Uh, in the name, there is a term known as aluminium hydroxide. Aluminium hydroxide is the common term known as the antacid. For our general gastric antacid disorder or gastric antacid problem, the drugs generally we take is the antacid of Square Pharmaceuticals Limited or any other form of gastric antacid. So aluminum hydroxide is basically is one of the ingredients of those antacid tablets. In the antacid tablet, there are basically two ingredients. One is magnesium hydroxide and another is aluminum hydroxide. And in this experiment number 2, we are going to manufacture aluminum hydroxide gel. So let's know what is aluminum hydroxide. Aluminum is a naturally occurring mineral. Aluminum is an element of element. Aluminum hydroxide is an antacid. Aluminum hydroxide is the salt of aluminum. It is basic in nature, and since it is basic in nature, it is used as an antacid for relieving gastric acidity problem. Aluminum hydroxide is used to treat heartburn, and you know that heartburn is a pain or discomfort in the upper chest and mid chest, possibly that may involve the neck and throat. This is the burning or pain or discomfort that is felt in the upper chest or mid chest. And it is also used for the treatment of stomach upset or sore stomach. Basically, sore stomach or stomach upset, these two terms are very much familiar, very much similar. And during stomach upset or stomach sore, there is upper abdominal discomfort, which is described in the form of burning sensation. The person who is feeling the upset stomach or stomach sore generally feels burning sensation in the upper stomach. He may have bloating or gassiness. He or she may feel nausea or feeling of full too quickly after starting to eat. And finally, it is used for the treatment of acid indigestion. Acid indigestion is also known as dyspepsia, and dyspepsia is the term that describes the discomfort or pain in the upper abdomen. Although it is not a disease, but it is a term refers to a group of symptoms that often include bloating, discomfort, nausea, and burping. Generally, indigestion is linked to the eating or drinking after a wedding party or birthday party. Eating a lots of stuffs, one person may feel indigestion problem, and whatever it is, aluminum hydroxide it is used for those types of problems. So aluminum hydroxide is also used to reduce the phosphate level in the people with certain kidney conditions. Okay, now let's move on the principle. Before going to the reading the principle, I am showing you the reaction that is the basic principle for the production of aluminum hydroxide gel. In the reaction, you can see that 3 moles of sodium carbonate react with 2 moles of potash alum in the presence of water and produces 3 moles of sodium sulphate, 1 moles of potassium sulphate, and 2 moles of aluminum hydroxide along with carbon dioxide. So the production of aluminum hydroxide gel involves a reaction that takes place between sodium carbonate and potash alum. And the reaction produces sodium sulphate. It is a salt which is insoluble. Potassium sulphate, it is also a salt which is also insoluble. Aluminum hydroxide, it is our desired product. It is insoluble and it produces a turbidity in the solution and becomes settled down very slowly. The byproduct is carbon dioxide. Carbon dioxide is gas and it easily escapes the solution reaction or the and becomes mixed with the environmental air. So Since sodium sulphate is soluble, potassium sulphate is soluble, and aluminum hydroxide is insoluble, so we can easily separate the aluminum hydroxide from the solution by filtering it, and that actually happens. After reaction, we have to filter the aluminum hydroxide with the help of filter paper, and after filtering the aluminum hydroxide, it is dried. Then the dried portion is weighed out, and after weighing, we have to calculate the yield value. Now let's have some principle. Let's read the principle. Aluminum hydroxide is prepared by reacting potash alum with sodium carbonate. Sodium carbonate and potash alum react and produces sodium carbonate and potash alum reacts and produces aluminum hydroxide and other soluble salts of sodium, soluble salts of potassium and aluminium, etc. With the help of filter paper, this insoluble gel-like aluminum hydroxide product is collected from the upper layer, and finally the aluminum hydroxide is dried, flavored and preserved with some suitable preservation and labeled. In the practical session, we have to prepare a solution of sodium carbonate, hot solution of sodium carbonate, another hot solution of aluminum hydroxide, and then we have to pour this hot solution of aluminum hydroxide into the solution of sodium carbonate. We have to pour aluminum hydroxide solution into the sodium carbonate solution, and we should not pour the sodium carbonate solution into the aluminum hydroxide solution. Why? Because if we pour sodium carbonate solution into the aluminum hydroxide solution, it will produce some adhesion. That means it will adhere the sodium sulphate and potassium sulphate on the surface of the aluminum hydroxide gel. That means it gets adsorbed on the surface of aluminum hydroxide gel, and the carbon dioxide generally entraps into them, and it cannot easily escape the solution to mix with the environmental layer. So we must add potassium solution into the sodium carbonate solution for the production of aluminum hydroxide gel. And after the production, we can use hot water for washing the sodium sulphate and potassium sulphate so that we can get pure aluminum hydroxide gel. So for the preparation of aluminum hydroxide gel, a hot solution of potassium is prepared, and it is added slowly to a hot solution of sodium carbonate, and the product after the production of aluminum hydroxide, the solution becomes starbit white, milky white color generally appears. Then aluminum hydroxide gel is washed slowly with hot water so that the potassium sulphate and sodium sulphate salt can be removed from the solution, and we only get aluminum hydroxide gel. After that, the gel is mixed with some hot distilled water, and then it is dried, and it is filtered with the filter paper and dried. After drying, then it is weighed out and the yield value is calculated. Now let's talk about some important note that the aluminum hydroxide gel is very light and it precipitates very slowly. If we use cold water is much denser than the hot water, so the rate of precipitation of aluminum hydroxide becomes slow. Since it is very light, the rate of precipitation of aluminum hydroxide is very slow. To get a faster rate of precipitation, we have to use hot water. But there is a problem with the hot water, and the problem is that if aluminum hydroxide gel remains in contact with the hot water for a longer period of time, or if we use very hot boiling water, then aluminum hydroxide is converted into aluminum hydroxide oxide. This aluminum hydroxide oxide is soluble in acid, and our yield value will be very low. We will lost our aluminum hydroxide gel, our intended aluminum hydroxide gel, and since our aluminum hydroxide will convert it into aluminum hydroxide oxide. So we should not use very hot water or boiling water. Instead, we should use only hot water, gentle hot water, and the contact time between the aluminum hydroxide gel and the hot water should be as low as possible. Now let's move on the calculation of yield value for the aluminum hydroxide gel. Uh, the amount of sodium carbonate taken for the production of aluminum hydroxide gel in this experiment is 2.5 gram. And we know that the moles of sodium carbonate is the amount of sodium carbonate divided by molecular weight of sodium hydroxide. Sodium carbonate, the molecular weight of sodium carbonate is sodium 106 gram, 106 gram. So we have to divide 2.5 gram with 106 gram, and it will produce the number of moles of sodium carbonate taken in this experiment. If we multiply this mole with 1000, that will produce millimole. The millimole is 23.6 millimole. Okay, now let's move on the reaction. You can see that from the reaction, 3 moles of sodium carbonate reacts with 2 moles of potassium and produces 3 moles of sodium sulphate, 1 moles of potassium sulphate, and 2 moles of aluminum hydroxide gel. So 3 moles of sodium carbonate produces 2 moles of aluminum hydroxide gel. That means 3 mole of sodium carbonate is equal to 2 mole of aluminum hydroxide. That means 3 millimole. If we multiply the mole with 1000, this will produce millimole. 3 millimole of sodium carbonate produces 2 millimole of aluminum hydroxide. And in the experiment, we have taken 2.5 gram sodium carbonate, which is equivalent to the 23.6 millimole. That is why 23.6 millimole sodium carbonate is equal to 15.733 millimole of aluminum hydroxide. So in the theoretical calculation, we will get 15.73 millimole of aluminum hydroxide. This is our theoretical calculation, but in actual practice the amount may vary. This may be greater than or less than 15.73 millimole. So after completing the practical, you have to wash the aluminum hydroxide gel, filter the aluminum hydroxide gel, dry the aluminum hydroxide gel, and get the weight of the aluminum hydroxide gel. After getting the weight, you have to put the weight in the position where the x gram is present. Practical amount of aluminum hydroxide gel obtained is equal to x gram, and you have to put your amount instead of x gram. The molecular weight of aluminum hydroxide is 78. By dividing the weight with molecular weight, we will get the mole. That will produce the moles of aluminum hydroxide. And if we multiple this mole with 1000, this will produce the millimole. So the practical amount will have this millimole of aluminum hydroxide. This millimole of aluminum hydroxide, if you put the amount of aluminum hydroxide instead of x, and this will give us the millimole of aluminum hydroxide obtained after practical. Now this practical amount will be divided with the theoretical amount. Practical amount divided by the theoretical value. This millimole is divided by theoretical value. Theoretical value is 15.73 millimole. So this millimole is divided by 15.73 millimole. And if we multiply this millimole with 1000, then this will give us the theoretical yield percentage. In this way, we will calculate the theoretical yield percentage for aluminum hydroxide gel. Now you can see how the practical takes place. After producing the aluminum hydroxide gel, you have to filter the aluminum hydroxide gel just like this. This is a symbolic picture. This is not the actual picture. This is a symbolic picture. You have to filter the aluminum hydroxide gel. The gel will be left over the filter paper, and you have to take the filter paper and dry in the dryer. Then you have to wet the filter paper along with the aluminum hydroxide gel, and you have to calculate the yield value. This is some practical insoluble salt. This is another symbolic step. You have to take the hot sodium hydroxide sodium carbonate solution in a beaker. You have to put a hot solution of aluminum hydroxide potassium. You have to take hot sodium carbonate in one beaker, then you have to take hot potassium solution in another beaker. You have to put this potassium solution into this sodium carbonate solution, and this will produce the gel. This gel, white things is producing the gel. This is the white turbidity. Then white insoluble salt is formed. Then you have to filter this white insoluble salt. That means filter the aluminum hydroxide gel. Before that, you have to wash the aluminum hydroxide gel. After filtering, when the filter is completed, then you have to wash the aluminum hydroxide gel with pure water, so that the sodium carbonate and potassium sulphate and sodium sulphate becomes washed away, and we only get aluminum hydroxide gel. After washing the aluminum hydroxide gel, you have to wet the aluminum hydroxide gel, and this is the dried aluminum hydroxide, semi solid or dried aluminum hydroxide gel. After drying, you have to wet the aluminum hydroxide gel and calculate the theoretical yield value. That's all about the preparation of aluminum hydroxide gel. Hope you have understood the theoretical part of this practice.